All right, you guys, so welcome back to Multiplying Polynomials Part 2. So we're going to be looking at problems that are a little bit more involved, okay, and making sure that you really are comfortable with multiplying polynomials as we work through this unit. All right, so our first example is 3x plus 1, 2x squared minus 5x plus 7. Okay, and I told you based on my last video that I'm going to utilize the box method to multiply. Now, if you're wanting to use the distributive property, you're welcome to do that. It's just going to make your problem very, very long across your paper. But you would simply take 3x and you would multiply it by every term, and then you would take 1 and you would multiply it by every term. Okay, for me, after all these years, that just gets really, really messy. Okay, so all I do is I set up an extended tic-tac-toe. I don't draw the full box, I never have. Okay, I just draw out an extended tic-tac-toe. Nothing goes here. Okay, and because I only have 2 rows, okay, my binomial is going to go here. So 3x plus 1 is going to go here. All right, and then my trinomial, because I have 3 columns, is going to go here. So 2x squared minus 5x plus 7. Okay, and I write down what type of term it is, because that way I know for sure that I'm multiplying correctly. Sorry. So now I'm going to multiply. So 3x times 2x squared, well, that is 6x to the third, because 1 plus 2 gives me 3. So you got to be very careful on adding your exponents. 3x times negative 5x is negative 15x squared, and 3x times 7 is 21x. All right, so now I'm going to take 1 plus 2x squared, so that's just 2x squared. 1 times negative 5 is negative 5x. 1 times 7 is 7. Okay. Now, when I combine like terms, okay, they should be located in the diagonals, okay, if you've set everything up right. So my like terms, okay, are here in these diagonals. So 6x to the third is on its own. So 6x to the third. Negative 15 plus 2, that's going to be negative 13x squared. 21 minus 5, that's going to be 16x, and then plus 7. So that is my final answer. So 6x to the third minus 13x squared plus 16x plus 7. Submit my answer. Okay, and you can see he does not even use the distributive property as his work example. Okay, it is just so much neater to put things in a box like this. Okay, and you're welcome to draw a box this way, okay, rather than doing the tic-tac-toe, whatever works for you. All right, so I'm going to do one more because the problems actually are not going to change. This is what they're going to look like regardless of the example. All right, so if I just go ahead, I'm just going to jump right in with my tic-tac-toe and copy it from Delta Math. I didn't do a very good job with that. I'm drawing them big because I'm taking notes. All right, so I'm going to put x plus 1 here. And then 3x squared will be here, negative 10x here, and plus 8. All right, so x times 3x squared is 3x to the third. Add those exponents. X times negative 10x is negative 10x squared. X times 8 is 8x. 1 times 3x squared is just 3x squared. 1 times negative 10x is negative 10x. And 1 times 8 is 8. So 3x to the third, my like terms hanging out in these diagonals. So negative 10 plus 3 is negative 7x squared. 8 plus negative 10, negative 2x. and then plus 8. Okay, and then remember it should be in standard form, meaning the exponent should decrease and your last term should be your constant. Okay, so your exponent should decrease and your last term should be a constant. So 3x to the third minus 7x squared minus 2x and then plus 8. Submit my answer. All right, okay, so that is how you're going to do your assignment, okay? If you've got any questions, please let me know, and good luck, you guys.